Alright, so this assignment, in short, is, so it asks you to make a 2D array of strings that you can manipulate. And the way you do that is, unlike the previous assignments with robots, this one requires you to make a non-flat 2D array. So I'll make a diagram on how to do that. So let's say you have a 4x3 grid. Well, to do this, you would need to first allocate an array of three pointers. So this will be an address, 0x200, 0x204, 0x208, because pointers take up, I think, 4 bytes. So you do this by saying pp data equals new int pointer, what was that, rows. Because you have 3 rows here, so you'd want to allocate 3 rows here. And then you'd have a for loop that says for 0 I less than rows plus I. Come on. Fuck it. pp data I equals new int columns. So you're allocating 3 arrays, and each of those arrays is going to contain 4 elements. So now you have a total of 12 elements allocated like this. This is what you should put in your constructor, because it says here, yeah, you're going to get rows and columns in your constructor, I think. So using that, you make the amount of rows and the amount of columns, and this is how you do that. Oh, and I should specify, you're going to have the empty parentheses at the end in your array of ints to set all the ints inside of it to 0. Because if you don't do that, you're just going to get a bunch of garbage data that was in your RAM. So you always add these empty parentheses. And then for deleting, you do the opposite of that. Always add the square brackets in your delete operations when you're working with arrays. And then you delete pp data. So this is for construct, and this is for delete. That makes sense so far. Alright, cool. Go to make the whiteboard larger. Alright, so we have create and delete done. So we now have our our data. We have a 2D grid. Instead of int, this should say string. I forgot that you were working with strings instead of ints. Okay, now what is the next thing we have to do? Usual big four. Alright, so the big four are, let's see. What's the big four? Default, copy, assign, shit, what was the other one? Was it conversion? There's nothing you'd be converting from. Probably destructor. These are big four operations that you need to do. I already went over the destructor and one of the constructors that you could possibly have. I didn't go over the default constructor, but I mean you could just put this in a helper function that takes a number of rows and columns, and then just put that in the non-default constructor. And then in the default constructor, call the helper function, but supply it 0, 0, so it allocates an empty array of nothing. And then later on, you can reallocate this array as you need. I don't imagine you'll have a default constructor for any reason, because why would you? It's good to specify a number of rows and columns, I guess. Let's see. That's not helpful. Okay, the copy constructor, you're going to do the following. So you have in your other table, you have a table of strings, and you need to copy this in. So you do what you did in the other constructor. You allocate the number of rows equal to the rows in the other table, and you allocate a number of columns equal to the columns in the other table. And then you fill in with the data from the other table. So that would look like yeah. So you're going to be doing this in your copy constructor and your operators equals because they do the same thing. You'll want a deep copy. And then after your helper function to allocate the table, you need to do a double nested for loop. It's going to say for I 0. And that's all you got to do for that. But note that in the operator equals, you have to first delete PP data and then reallocate with the allocate table function. The copy constructor, you don't have to do that because there's not already a table yet. But in the operator equals, you do have to delete the underlying table and then reallocate with the helper function. That's this thing. Because let's say you have a 2x2 grid, but you're being assigned a 3x4. Well, to copy the data in, you have to have a new table. But if you allocate a new table, you're going to have a memory leak unless you delete the old table. So you delete that with this deletion stuff right here. Wait. This error doesn't need to exist. There's no ints here. Okay, that goes over that. Default copy assign destructor. Alright, what's next? That's just formatted output, which we can go over later. Position access is pretty easy. Okay, so you need to overload the operator, this operator. And it will take an int I, or it'll take an int row, an int call. So you just need to return. Actually, I just need one line. And that's all you got to do for that one. And then you'd call that, so you'd have by doing the following. So you have table T 3 4, and then you do table 1 2 equals string. So you're going to have two versions of this. One returns a string, and the other returns a string reference. The one that returns a string reference is not const, but the one that returns a string is const, because if you just return a string, you're returning a copy of it, and if you return a copy, there's no way you're going to be able to modify the underlying this pointer. But if you return a reference, then you can modify the contents inside the class, so you're modifying this, so it can't be const. Yeah, it's written right here, basically. Overloaded reverse. So you have 3 reverse operations that you need to do. So these are some sample strings in a table. Banana, apple, Bob, taco cat, string, and table. Now the first one, or the first reverse method, reverses a string at position ij, so it takes two ints, it takes a row and it takes a column. So let's say we have row 0, column 1, so that will be apple. So you have to take the word apple and reverse it. Okay, simple enough. You can use I think there's an STD method or STD function called STD reverse, and it takes an iterator at the beginning and an iterator, or it takes two iterators, but you'd usually supply like string.begin parentheses and string.end parentheses. You can look those up online to know how to do that, but that's the simplest way I can think of to reverse strings using the STL. Second, reverses the row at position I. So let's take this row. So it doesn't reverse any strings, it just reverses the order of the strings. So you'd get taco cat goes over here to the end. And table would go to the beginning. And since string is in the middle, it doesn't move. Now, the one that takes none, the one that takes no arguments, does something a little more complex. It swaps the rows and columns, so now you have, instead of a 3x2, you have a 2x3. So this will say, in a table, Elpa, Bob, and taco cat. And that's more or less a high-level overview on how you do that. As for a low-level overview, I would say, what? So you would allocate a new table with, instead of doing rows and columns to supply the rows and columns, you'd actually do columns rows, because that swaps the order. So temp equals instead of rows columns, you do columns rows. Yes, this is exactly what that does. This is exactly what it does. So if you've done this in CS230, then you'll know how to do this this operation here. It's not too bad. You can just use the code used for that. Except instead of ints or doubles, you're using strings. But since it's just a different data type, that doesn't really affect the algorithm itself. So I trust that if you're taking CS230 viewers, you will know how to do that. But if you're not, I don't think anyone in CS170 is not taking CS230, so I think that'll go assumed. If you don't know how to do that, you can send me a private message, and I'll be more than happy to send the algorithm to you. Alright, operator plus. This puts one table over the other to merge into a larger table. So you have this, and you have this. And they merge like a Power Rangers Megazord or something into a big-ass table. Yeah. So, to allocate the table, you'd find max rows equals standard max so you'd find the maximum of the basically which is larger. It's a son of a bitch. There we go. So you find the larger of the two. So this is, let's say, 3, and this is 7. So you're going to have 7 columns and 5 rows if this is 2. So you allocate 7 rows and 5 columns, and you do helper function allocate table. I'm just going to call it HFAT because it is longer to type that instead of the HFAT. So HFAT max R max columns. There we go. Temp equals that. And then, so you'd loop through every element in this table, and you do like table or temp table ij plus equals this table's position at coordinates ij. That way, because it starts off empty, so if you do plus equals, it adds the current string in the cell you're in to the empty string, so it first becomes this, and then you do the plus equals to like R or cell ij or temp table ij plus equals RHS ij. So if you have an empty string there, like you'll have over here, you'll have the empty string plus the RHS at that one. But these won't be empty because you just supplied them with the strings in the first table. So you're adding the second table on. So you do, temp table ij plus equals RHS ij. So you're concatenating on the second table. So you get a mix between the first table and the second table here. And you get these are just the first table, and this is the second table, and these are going to be empty since none of the tables have any data here in this region. Does that make any sense? Okay. As for implementation, that'll just take some time in figuring out. I went over the basics of how to implement it, but the specifics I leave up to you. The tensor product, the thing I was most dreading in this overview because I have the least understanding of it. Let's see. You have a 2x2 and a 3x2. So that means you allocate a 6x4, it looks like. So you multiply the first width by the second width to get the total width. Multiply the second height, or the first height by the second height to get the total height. And then you distribute the term. So you do A plus X. Okay, I get it. So if you have a string here, it's basically matrix math, yeah. Okay, so yeah, you'd add the A string to each of these. You'd add it to X, Y, Z. So you have A plus X, A plus Y, A plus Z, and you keep doing that for all of the terms. So you add them all together eventually to get this total thing here. Any questions so far? That is a typo. Alright. I wasn't the one that wrote this, so don't blame it on me. Blame it on the big V, man. Alright, now that's proper. So now all the C terms are distributed. Yeah, typos are fairly common in these handouts. They're not like peer-reviewed or anything. So I wouldn't be surprised if one slipped by. There are a couple comments here at the end. Make sure driver 1 compiles. Make sure the second one does not compile. That's a little odd. I wonder why. T. Oh, that's because it's const. Okay. So he declares a const table, and he tries to use the const get method, and then assign it to an R value, which is const. But you can't do that because it's constant, would modify the interior of the constant this, but you made a contractual agreement to not modify the contents of the const. Okay, so this should not compile, but this should. Okay, that makes sense. Alright. And that is the basics of what you need to do for this assignment. I think the most complicated thing in here is going to be the third reverse and the multiplication operator. So I would do those last. And that's just about it for the handout. I'm not going to like type this out, or I'm not going to program the whole thing in front of you guys, because I want you to do the implementation yourselves, unless you have any questions for me during implementation. But if you have any last minute questions for me now, before I wrap up, because I don't really have any other content to go over, then I'll be happy to answer any questions about the assignment or about anything else. Okay. Cool. Well, if no one else has any questions, speak now or forever hold your peace, and I will stop the recording.